We are going to look at the following questions based on climatology and geomorphology. I believe you are set to go. Firstly, we are doing question 1.1, which says, refer to the figure 1.1 showing a stage in the development of a mid-latitude cyclone. Choose the correct words from those given in brackets. Write only words next to the question number in the answer book. As well, you might have been told that in exams, that is an instruction where when they say you write the answer next to the question number. Therefore, let's go straight to the first question, 1.1.1, which says a mid-latitude cyclone is also known as, in brackets, coastal low pressure stroke extratropical cyclone. Let us go see the addendum. So this is our addendum, or the figure of a mid-latitude cyclone. As you can see here, we have the polar front, we have the warm westerly winds, and as well we have the cold easterly winds. Therefore, we go back to the question and we look. It says a mid-latitude cyclone is also known as a coastal low or extratropical cyclone. And for our answer, it's going to be the extratropical cyclone. Reason being, it cannot be a coastal low because we all know that coastal lows, for example, as I indicate here, these are low pressure systems that develop along the coast and they move from the west to the east along the coast. So this will be a coastal low. For our answer, it's supposed to be the extratropical cyclone. That is for question 1.1. 1.1.2, it says the mid-latitude cyclone in figure 1.1 develops, in bracket, southern stroke northern hemisphere. What could be the answer? Let us check the figure and we see. The question says that the mid-latitude cyclone does develop in the northern hemisphere or the southern hemisphere, according to this figure. As we can see here, look at the warm westerly winds and look at the cold easterly winds. If you were to examine, going back to, let us try to indicate our global winds, where this is our equator at 0 degrees, as all know. This is the south hemisphere, and we have the northern hemisphere. Now, the question is this mid-latitude cyclone situated in the north or situated in the south? But the best way to understand this question is you need to understand the movement of the winds. Let us try to indicate, to label the winds in the southern hemisphere. Let me remove these two, since now we know southern hemisphere and northern hemisphere. Now, we know that in the southern hemisphere, we're going to have our polar easterly winds, our easterly winds in that direction, and we shall have our warm westerly winds in that direction. So this is the westerly winds, and down here we have, we have the cold easterly winds. Here we have the warm westerly. Now, if you look in the northern hemisphere,
GPS signal lost.
If you look in the northern, sorry about that. If you look in the northern hemisphere, we're also going to have the westerly winds. So shall have the easterly winds. I wanted to look at the pattern of these winds. If we check in the northern hemisphere, look, this is the cold easterly winds, and this is the warm westerlies. This applies in the northern hemisphere. If we check in the southern hemisphere, look at the pattern of the warm westerly winds and the cold easterly winds. Therefore, if we check on our figure, you can see this is the westerly winds, as you can see there, and this is the easterly winds. If we compare this to this diagram here, if you look in the northern hemisphere, look at the westerly wind. They are in this other position like this, you see, and the easterly like this, which is not similar to what we see in this diagram, which means we take out that one. Let us check the one in the southern hemisphere. If you check in the southern hemisphere, look at the westerly winds, the position, the westerly winds. So if I check, this is the westerly wind, and if I check again here, this is the easterly winds, which is this one here. So which means that this MLOC, which we refer to as a mid-latitude cyclone, was situated in the southern hemisphere by the mere fact that the westerlies are situated on top and the easterlies are situated at the bottom, which is clear here. We have the warm westerlies situated on top and the cold easterlies at the bottom. And if you check on our figure, this is the warm westerlies on top and the easterlies at the bottom. So our answer then is supposed to be southern hemisphere. Question 1.1.3, it says a mid-latitude cyclone is a high or a low pressure system. What does that mean? We all know that it is being called a cyclone, and all cyclones are low pressure systems. So a mere fact that you understand that we have a cyclone and cyclone, it means that this mid-latitude cyclone is going to be a low pressure system. I hope we are clear on that. Question 1.1.4. The stage of development shown in figure 1.1 is the wave stroke mature stage. Let us check once again. If we do check on our figure once again, they're saying, is it wave or mature stage? Now, the mere fact that we all understand that a mature stage, there must be at least the visibility of a cold front and a warm front. I believe all of us know the symbol for the cold front and the symbol for the warm front. This will be typical of a mid-latitude cyclone in the mature stage. But if we check on our figure once again, we are only seeing the westerly winds and the easterly winds and the polar front, which means the cyclone or the mid-latitude cyclone, it is still developing, which means it is in its wave stage. Check again here. If we check at the polar front, you see there is a depression which has developed, which is in form of a wave, which is also an indication that this MLOC is still in the wave stage. So our answer for this will be the wave stage. Question 1.1.5, it says a mid-latitude cyclone moves in the stroke an easterly stroke westerly direction. Now, this question talks about the movement. And we all understand that movement, it refers to moving from one point to another point. In most cases, learners do confuse this question of movement with the rotation. Rotation is something, it is spiraling around, but movement, it means you are moving, for example, from, let's say, Pretoria going to Johannesburg, or from Johannesburg to Cape Town. That means there is a movement from one point to another point. So for this case, with the same movement, if I use this arrow here, now this shows that someone was moving from point A, that's point A. Let me change my handwriting here quickly. Sorry about that. So it means someone is moving. This is point A. That's point A to point B. So it means that boy to male is moving from point A going to point B. If it's like this, then they ask you, in which direction was boy to male moving to? Then it's a boy to male moved from direction A towards the point B, which is supposed to be from east to west. However, if we go back to our question after that illustration, which says in which direction, so it's going to be the easterly direction, because we know that mid-latitude cyclones, they move from west to east. Sorry, let me change again. Yes, they move from west to east. In sometimes, some question could be, they could just indicate only, they could say west to east, or it could as well be the same as from west to east or easterly direction. It means the mid-latitude cyclones, they always move from west going to the east or to the easterly direction. I believe we all understand or know why that happens, because the MLC, which I usually abbreviate, meaning a mid-latitude cyclone, they develop in the westerly winds. And the westerly winds, we all know these are global winds which move from the west, move towards the eastern direction. So if the MLC, for example, if I can illustrate it here, these are our winds, which are the westerly winds. Why do we call them westerly winds? Because they move from the west to the east. We know that winds are named from the direction where they originate. So these winds are originating from the west, going to the east. That's why they are being called the westerly winds. It is the same as, let's say you are a South African and you'd like to move or to locate to USA or to move to USA. When you go to USA, if they ask you, who are you? You're going to say, I am a South African. Why? Because you originate from South Africa. So the same apply to these winds. If the winds come from the west, these winds are going to be referred to as the westerly winds. Therefore, if we have a mid-latitude cyclone developing in these winds, for example, it means that this mid-latitude cyclone will be driven in the same direction of the winds, from the west going to the east. So that is why we say our answer was supposed to be the easterly, meaning where they are moving to. They are moving to the east, but they come from the west. Question number 6. It says a mid-latitude cyclone has a greater influence in South Africa. In bracket, they put summer or winter. All of us know that these are different seasons. We have summer, where we know it is always, temperatures are always high, and in winter, temperatures are going to be low. But you all understand that mid-latitude cyclones, they don't have a specific season of development, unlike the tropical cyclones, which form only in summer. For the mid-latitude cyclones, they can as well develop in summer or in winter, provided we have the polar easteries and the warm easteries. That is why the mid-latitude cyclones can develop in whichever season. However, the question is asking, a mid-latitude cyclone has a greater influence in South Africa. Is it in summer or winter? And for this case, our answer is going to be winter season. Why do we say winter season? Let us try to illustrate, see if you can understand it a bit more. Let me try to create some space here, or let me try to use this blank page. So we say that they usually affect South Africa mainly in winter season. Let's try to draw a sketch map of the map of Southern Africa. We know that the pressure belts, they migrate. In summer, the pressure belts migrate further southwards. That is why in summer, we usually see the mid-latitude cyclone located far away from South Africa. So this is typical of summer season, meaning that in summer season, the pressure belts, they move further south. If they move further south, it means this results into the mid-latitude cyclone as well to shift further south away from South Africa. But if we compare this with the one in winter, this is winter. Remember, it is a sketch map. Now, winter season. Winter season. In winter, we know that pressure belts, they migrate northwards, meaning we're going to see the high pressure cells moving further north, and as well the mid-latitude cyclone also moving further northwards. So you can see that in winter, due to the migration of the sun or the ITCZ, it forces all the pressure belts to shift northwards in winter. That's why we can see that the mid-latitude cyclone is able now to influence South Africa in winter, but not in summer. Because in summer, we said that the pressure belts, they do shift further south. That is why you can see these high pressure cells, they're as well being found further southwards. And the mid-latitude cyclone, it is also located further southwards. You can see there is a greater distance between the MLOC and South Africa. This is in summer. But in winter, look, it has moved close to the land or close to South Africa, which means that our answer for this case is going to be winter. Okay. Moving to question 1.1.7, they say line A is the 40 degrees stroke 60 degrees latitude. What are latitudes? all know latitudes. Let's go back to our blank page. Latitudes. Latitudes. Okay. Remember, these are imaginary lines. Imaginary lines which run horizontally from the east to west, horizontal. So when I say horizontal, if I try to draw our globe here to show what latitudes are, illustrate them. So we say this is a horizontal line, and we have the major line of latitude, which is the equator, which is numbered 0 degrees. We have another major latitude, which is at 30 degrees. Another one at 60 degrees, and so forth. 90 degrees. Don't forget, this is the northern hemisphere. Northern hemisphere. And we all know whatever happens in the north also does happen in the southern hemisphere, meaning if we do have 30 degrees in the north, we as well have the 30 degrees to the south, because we know that latitudes, they increase northwards and southwards. So this is 0, 30, they're increasing from the latitude, 60 degrees. We also have another one which is 90 degrees. So you can see that these are the different, when you say imaginary lines. When you say imaginary, it means when you go there physically, you can't see this line and you say, oh, this is the latitude. No, they're just imaginary lines which are invisible, but we know they are there, but they are drawn horizontally from the east to the west. Now, going back to our question, it was saying line A, is it a 50 degree or is it a 60 degree? Okay, so this is our line A here. Our line A. Let me go back to our blank page for more illustration. Now, we know that mid latitudes, there isn't the word mid. So if I remove the southern hemisphere, let me remove the northern hemisphere, for example. Let's see if it will work out the way I want. Oh, no, it won't. It won't. How do I go back? Let's see. Okay, let me try to do this one again. Technology. Let's see. Okay. What's happening now? All right. Sorry about that. So I was saying, let's try to do this again. I'm sorry, technology disappointed me. All right. Anyway, we all know that the world is not round, it's kind of oval. So I was saying, if we focus, these are the polar regions. Polar region is here, where we know it is very cold. Just say cold, and we know winds that are coming from the polar regions are going to be cold winds, right? So we have our easterly is there, and these are the subtropical belts here. I think let me try to redo this again. It's not doing what I want. All right. Try to make things very, very clear. I'm going to redraw our globe. Okay. Draw. Because we need to understand, not to rush, but to understand. Okay, this is the equator, like we mentioned, at 0 degrees. That's our major line of latitude. We have the other one, which is 30 degrees. We have another one, which is 60 degrees. Another one is 90 degrees. So, like I mentioned, whatever happens in the north does happen in the south. So I have the 30 degrees there. Don't forget it's a sketch. We have the 60 degrees and we have the 90 degrees, right? So these are the polar regions here, like I mentioned. The polar region is polar, which refers to the coldest areas. Then here, this is the equator, which is warm. So meaning the winds that are coming from the equator, these winds here, these are going to be warm winds. These are the winds that are coming from the polars are going to be now referred to as the cold winds. This is in the in the north. And as we know that mid-latitude cyclones, they develop where the warm winds and the cold winds meet at the polar front. So mean that this point will be our polar front. So this is in the northern hemisphere. If we go across the south, in the south as well, we do have the warm westerly winds. These are our westerly winds, and we have the cold easterly winds. Now, where do they meet? We go back to the other concept of a front. What is a front? A point where different air masses collide or meet. So meaning at this point here in the south, this will be our polar front. Then you ask yourself, which line of latitude are they meeting at, or are they colliding at? As you can see, they don't meet at 0 degrees, they don't meet at 30, but you can see they are meeting at this line, which is 60 degrees. Of course, further could be somewhere here, but our focus is we look at the easterlies, which are coming from the polars. When they come, they are both meeting at this point, which is our polar front, situated at 60 degrees. So meaning that our answer was supposed to be 60 degrees. All right, let's move on. Question 1.2. They say, choose a term from column B that matches the geomorphologic description in column A. Write only the letter A to I next to the question number 1.2.1 to 1.2.8 in the answer book, for example, 1.2.9J. This is an instruction which all of you must understand, that you use letters, not words. All right. Okay. Remember, they say choose a geomorphologic description. Sorry about that. About I need to get, I think, a ruler. They say choose a geomorphologic description which matches a term in column B. Right. 1.2.1, it says the lengthening of the streams at its source due to the erosion of the watershed. What is to lengthen? Let us try to check on our blank page here. Lengthening. I'm going to give an example. Let us assume that this is a watershed. And this is a stream flowing. So it means that this point would be the source. And this point would be the mouth. So if I measure the length, for example, from the source to the mouth, if I try to measure using a ruler, for example, it could give us, let's say, yes, we're just estimating, let's say 2.7 centimeters, right? Okay. But if you look at this other one here again, this is our watershed. For that case, watershed, then you can see that this river was able to erode through the watershed, you see, and the source extended to that point, you see. And if I measure from the centimeters from here to the mouth, it could give us, let's say, 2.9 centimeters. You see? So meaning that before this river was able to cut through the watershed, it was 2.7 centimeters in length, or it was long by 2.7 centimeters. But if you go to this one, if you check again, the river, after cutting through the watershed, it was able to extend, meaning that its length was extended from 2.7 centimeters to 2.9 centimeters. All right. Let's check the question again. Question says, the lengthening of the stream at its source due to the erosion of the watershed. Okay, the lengthening of the stream at its, let me check the question once again. The lengthening of the stream at its source. Remember, they're using this concept, they're saying at its source. Lengthening at its source. And I try to show it here. This is before the lengthening. This is the source. This is the watershed. But you can see here, this river is flowing to the southeast or southwards. But you can see it was able now to cut. This was cutting to erode through the watershed, whereby now it's whatever course had been lengthened, or it has been stretched a bit further. Now, what is that called in geomorphology? If you check on the concept, water table, dendritic, drainage, it's going to be headward erosion. So the concept or the correct answer for this case is going to be headward erosion as our answer. Sorry, not drainage. Instead, it has to be headward erosion. What is headward erosion? When a river erodes backwards towards its source, lengthening its channel. So that's what we refer to as headward erosion. Okay. 1.2.2, they say river in a humid climate where the rainfall exceeds the evaporation. River in humid climate. When they say humid climate, sorry about that. When they say humid climate, humid could as well refer to areas which receives more water. Okay, more water, or always wet in most cases, always wet. That's why here they is saying rainfall. And what is evaporation? Evaporation, as we know, a process whereby water changes from one state to another state. For this case, it will be water changing from evaporation, so water changing from liquid to vapor. That is evaporation. So it's a process. Like we know that water is the only substance that you can find in many states. It can be a liquid, it can be a solid, which is ice, or it can be vapor, which is gas. Now, for water to change from liquid to vapor, there is a process which we refer to as evaporation. All right. Now, they're saying areas or a river in a humid climate where the rainfall exceeds evaporation. So it means this river, where it starts from, there is more rainfall as compared to evaporation, meaning you will always find water in that particular point. But let us see the vice versa of this statement. If, for example, it said where evaporation exceeds rainfall, it means in such areas, when you go there, you won't find water. You see, it means all the water is going to evaporate and it will disappear. But a point, sorry, right, but so a point where rainfall exceeds vapor or evaporation, it means that area there will always be rainfall. So which type of river will that be? Will it be because we check on the options, we have the episodic river, and as well we have the permanent river. But we know episodic rivers, these rivers, they only flow at a certain point when there is heavy rainfall. And permanent means this one is always there. It's always gonna be flowing. You see, that is why when we check on our options, we are going to say that it has to be the permanent river for question 1.2.2. Question 1.2.3, they say a section of a river drawn across the valley at right angles to the river. A section of a river drawn across the valley at right angles to the river. What is that going to be? Our answer is supposed to be E, which is a cross profile. A cross profile. Let us see a cross profile in details. A cross profile. So what is a cross profile? We say this one shows us the shapes of a river at different stages. Again, if you look at the upper stage or the upper course, the shape will be deep and narrow. See, if we check the course, the river in the middle course, the shape in the middle course, which they usually refer to as the mature stage. The shape will be wider. And if you check the shape in the lower course, the shape will be almost flat. Now, how do we arrive at these different courses or these different shapes? It means to be able to get the shape of a river at a different course, we apply the concept of a cross profile, where it says, for example, here, a section of a river drawn across the valley at right angles. Whenever we draw a section of a river, let's say, let's try to do something here. So when they say across, this could be the river banks, this other side. This is the channel itself. This is water. This is water. Now, if I'm to draw a cross profile around this point, it means when they say this is river bank A and bank B, which is the sides of the rivers or the edges. It means to get the shape of this point, I need to draw across a right angle. You see? Then I'll end up having something which is wider shape. So for our answer for question 1.2.3, that's why we say it's supposed to be a cross profile, because a cross profile will be able to see the different shapes which are drawn across the valley at right angles. Question 1.2.4. The drainage pattern that is formed by the folded mountains. 1.2.4. Could it be, they're talking about a drainage pattern. What is a drainage pattern? The concept here is a drainage pattern. And we all understand that this refers to the shapes. The shapes of rivers, or I can also say the appearance of rivers as seen on surface. That would be a drainage pattern. Sorry. But we know that rivers do not have the same pattern or the same shape. Like human beings, we have different shapes. You see? For example, if you look at your colleague, your neighbor, your classmates, they're different shapes of us. I normally tell my learners that if you look at the shapes of our heads, you can find they are way different from each other. So as well, rivers also have different shapes depending on which type of rocks they do develop on. That's why we say for 1.2.4, the answer is supposed to be trellis. Trellis pattern, they develop in areas which have folded mountains. When they say folded mountain, what are we looking at? Folded mountains, folded. Okay, if I illustrate it here, it could be something like this. That's a folded area. So if this is the main stream, for example, here, the main stream flowing, it's going to have tributaries joining from these steep areas, connecting at 90 degrees, and will end up forming a trellis pattern. It means that one side is folded where we have a syncline and an anticline. So because of that, you can see we have the main stream in the middle, but we have tributaries that are flowing from a steeper point joining the main stream, and also this other side we have tributaries that are coming from a steeper point joining the main stream. So they'll end up forming a trellis pattern. So this is common in areas which have folded mountains. As you can see, this is a fold here. That's a fold. I have a syncline here. This is another fold here. So because of these folds, if rivers are flowing in such areas, you end up forming a trellis pattern of flow. 1.2.5 occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. Now, our concept here is the word a watershed. If we check, this is our watershed here, and okay, so this is a watershed. Now, what is a watershed? We go back to our page here, try to understand the concept of a watershed. And I believe if you check in your textbooks, it refers to a highland that separates different drainage basins or different rivers. That is a watershed. Now, if we were to illustrate this, let's put that's a highland. You can see it's been raised. It's a watershed. Now it means on one side we have a river flowing. Let's call this river A. The other side we have another river. Let's call this one river B. Let's check the question once again. Excuse me. The question says it occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. So there are two concepts. Firstly, we understood what is a watershed. Now they are saying there is a more energetic stream and a less energetic stream. When they say less energetic, it's the same as a weak river. When they say energetic, the same as a stronger river. Let's go back to our diagram. You can see that this other side is a bit steeper, as you can see, compared to this other side, which means rivers which flow on a very steeper gradient, they become more energetic. In this one, which flows on somehow relatively gentle, we can refer to this as a less energetic stream. Now, we have understood the two concepts here. The first concept is a watershed. Another concept, energetic, less energetic, and as well we have the watershed, which is a highland. So meaning this land, it is separating river A not to mix with the river B. But as you know well that when rivers are flowing, they keep on eroding materials away. You see? They keep on eroding materials away, which means, let's say, this is the point of the watershed at X, and let's say it was in 2009. That was the position of the watershed. But if we check again, after several years, you see, the watershed height has somehow reduced. This is now the watershed at point X again. Now this is in 2050. 2050. I know most of you will still be around, but if you compare the height of this watershed and this one here, the watershed here has somehow reduced, which means it is getting lower and lower. Let's check again the watershed in another year. It's the same watershed, but it keeps on changing the size. You see? Now this could be in 2093. You can see that the watershed has changed the position, or its height has gradually changed. So if we compare watershed in 2009, watershed in 2050, and the watershed in 2093, you can see that the height has simply reduced. If we go back to the question, now we have understood what they mean when they position, when they say the position of a watershed changes. What is that concept? What is that term referred to when they say occurs when the position of a watershed changes? So that will be point H, which is abstraction. So abstraction refers to the change in the position of a watershed due to more energetic stream that flows parallel to a less energetic stream. All right. Let's proceed to question 1.2.6. A drainage pattern associated with a uniform underlying rock structure. Excuse me. Now, there are two things to also understand here. They're saying uniform underlying rock structure. Don't forget, we spoke about the meaning of a drainage pattern, and we said it refers to the appearance of streams or the appearance of rivers or the shape of a river. Now, a river which is associated, the word associate is the same as rivers which flow in such areas where the rocks are uniform. Now, if we check here, if I scroll down, say the word uniform. Uniform simply refers
GPS signal lost.
look similar in the way they erode or resist erosion. Okay, that is uniform. So uniform, like that's why most learners in high school, primary, they put on uniforms so that they could look the same. We can easily identify them. For our rocks, which are uniform, these are rocks. So it's like these rocks, they erode at the same time or they resist at the same time. Now, rivers which flow in areas which have uniform underlying rock structure, they will end up forming a pattern which is commonly known as a dendritic drainage pattern. So for 1.2.6, the answer will be dendritic drainage pattern. Let's proceed. 1.2.7, which says the upper surface of the zone of saturation in the underlying rock structure. The upper surface of the zone of saturation in the underlying rock structure. What does that mean? Okay, let's try to illustrate here. Once again, now for this question, you need to understand two concepts here. we have to understand what is surface runoff, which refers to water that flows over the surface during rainfall, to be surface runoff. And as well, we have another concept, which is infiltration. And this refers to a process whereby water seeps into the rocks, or you can as well say into the ground, So that will be infiltration, right? If you try to illustrate this on the diagram, this is the surface, for example, our surface. So this is the surface. Now underneath we have rocks. These are rocks, different layers of rocks. Be sedimentary. So these will be the rocks. Then here we have our precipitation or rainfall. You can see this is our rainfall. And we said when it rains, different processes are taking place. We see water which is able to flow over the surface, and refer to this as the surface runoff. Right. Not all water just flows over the surface. Like I mentioned, when it is raining, we're able to see water flowing over the surface. As well, some water is able to penetrate into the ground or into the rocks. You see? Now, the one which is able to penetrate into the rocks. So this process is what referred to as the process of infiltration. The process whereby water is able to penetrate into the rocks. Right. Now, the water that flows over the surface, for example, this water can flow into rivers or streams, but the one which flows into the rocks under the surface, this water is going to end up correcting. It collects here, forming for us what we call as the underground water. Remember, you can't see this water because it is hidden under in the rocks. You see, so we can call this water underground water. Or what as well referred to as the base flow. Now, how is this water able to reach here? Because it was able to penetrate through the rocks. Right. Now, like I mentioned, this water is under the ground. You can't see it with your eyes because this is the surface. This water is just hidden inside the rocks. So this water is what we refer to as the base flow or the underground water. Now, I want us to focus on one thing here. I believe you can all see this point here, this part here. That point, that part. So that is the upper surface or the upper limit. We have the bottom part of the base flow. It's the bottom part of the base flow, the bottom part. Let's call this one point X. And the upper part, let's call it point N. See, now the upper part of the base flow is what we refer to as the water table. Referred as the water table. So basically, when you go back to our question, which says the upper surface of the zone of saturation in the underlying rock structure. So this is the zone of saturation here. The whole of this, it is the zone of saturation. Saturation zone where water is able to settle or to squeeze itself through the rocks and it forms the base flow. But this base flow, or what we call the underground water, it has the upper surface or the upper limit, which I said we can refer to as the water table. All right. So meaning our question for 1.2.7, which says the upper surface of the zone of saturation in the underlying log structure, that will be option A, which is the water table. All right. Go to question 1.2.8. The arrangement of streams and rivers in a drainage basin. I believe we have spoken about that one before. So the arrangement of streams and rivers in a drainage basin, that would be a drainage pattern. Because the way they are arranged, what does that mean? Now let's go back to our blank page. So the arrangement. So it means some rivers are arranged in such a format. This is the main river. It has tributaries. It has tributaries joining like that. So the way the tributaries are arranged, you see, it will end up giving us a shape which all of us know, which we call the dendritic. Some rivers are arranged in such a shape or such a pattern where we see streams joining at right angles. And such a basin, we're going to refer to it as the trellis pattern. You see, so if you check our question once again, it talks about the arrangement of streams and rivers in a drainage basin, which is the same as the shapes of rivers or the appearance of rivers. So the way they are being arranged, it will end up giving us a shape, right? So we have dendritic, trellis, we have rectangular, where the main stream has bends because it flows over jointed rocks. So this could be the rectangular. We have the centripetal, where streams flow towards one central point. It means they're coming from a higher point, going to a lower point, giving us centripetal. So this is a rectangular pattern, and this is centripetal. We as well have the deranged pattern, where streams don't have a clear pattern of flow. You see? And this one we call it deranged. which is most common in glacial areas. So this will be the ranged drainage pattern, deranged. All right, common in areas which have ice, deranged, among other. So this is just an example to show you how streams or rivers are being arranged. So it will end up giving us different shapes, which we refer to as the drainage pattern. All right. So that is question 1.2. Let's proceed to question 1.3, which says, study the synoptic weather map in figure 1.3 to answer the questions that follow. All right. Now let's check the figure 1.3 for more information. This is our figure 1.3. I hope you can see we have the map of Southern Africa here. These are some of the things that you need to first identify when being given a synoptic weather map. South Africa, there's a low pressure cell over the interior. We have a high pressure cell the other side, another one this way. There's a stationary model here which has been enlarged for this from this point. And as well, you can see there is a cold front here, another cold front here. We have isobars at this particular point, and you can see pressure decreasing towards the low pressure cell and increasing towards the high pressure cell. So they say this is Durban here. They show us time and the date at this point here. All right. Let us now go back to the questions to try to understand. They say, identify the high pressure cell A. Let's check the question once again. They say, identify high pressure cell A. High pressure cell A. Now, as you can see, this is our high pressure cell at A. And of course, we know that the one which forms to the west of South Africa or Southern Africa. Of course, this is Southern Africa. This is our Southern Africa or South Africa in particular. Now, this is the western side, and this is the eastern side. And we know here it is the Atlantic Ocean. So we have the Atlantic Ocean, which develops over the western side. So meaning that the high pressure cell which is found at point A, it will be referred to as the South Atlantic high pressure cell. South Atlantic high pressure cell. Or we can as well give it another name, which will refer to it as Saint Helena. Saint Helena High. That is found to the west of South Africa. Now, since we have spoken about South Atlantic High found to the west or St. Helena, remember it has two names. It can be referred to as St. Helena High or South Atlantic High. Now, this one which is found to the east of South Africa. So we're going to refer to this as the South Indian high pressure. It also has another name. It has another name which I could as well, if I go back to our blank page. But we said that we have South Atlantic South Atlantic high, in bracket, St. Helena high. And as well, I want us to talk about the other one found to the east, which is South Indian high, or can as well be called Mauritius high. Right. Okay. So for our question 1.3.1, we said identify the high pressure cell at A, which is we said supposed to be South Atlantic high pressure, or Saint Helena high. On mark. Question 1.3.2, identify the front at B. Identify the front at B. This is our front at B here. As you can see, this is B here. We're referring to this front here. And which all of us know, it means we look at the symbol. This symbol which looks sharp pointed, or which looks, in some books they show it as a triangle. So for this case, it will be a cold front. So meaning for question 1.3.2, it will be a cold front. Right. 1.3.3, they say give the air pressure at A. Give the air pressure at A. So give the air pressure at A. Let's check A once again. All right. So if we check, this is A here. We look at the isobars, 996, 1000, 1004. So you can see the pressure interval is 4, because when you add 996 and you add 4 to give us 1000 plus 4, 1004 plus 4, 1008 plus 4, 1012 plus 4, 1016 plus 4, 1020 plus 4, which gives us 1024. What does that indicate? It means you can see that pressure is increasing towards the center, which typically means that this is a high pressure cell, right? Now, if they say what is the air pressure at A, you see, so it means we could say, because we don't see any isobar here, so we cannot say the different. We cannot bring in the isobar interval here, because we don't see any other isobar. If it was like this, we are going to easily say, just going to add before, and we say 1028. But the challenge is there's no isobar to indicate the missing figure. Therefore, what do we do for that case? We could say that at A, the air pressure is increasing. So you could say that the pressure at A, it is increasing, or we could say it is a high pressure, or we could as well say the pressure, it is 1025, 1026, 1027. So just add 1, you see. So you could as well say it is 1025, 1026, 1027. But we do not give the pressure interval, because there is no isobar which has been indicated. Like I mentioned before, we don't have any isobar here. If it was an isobar, we could just going to say we were just going to use the pressure interval. For this case, we know that the pressure at A, it is increasing, or it is a high pressure. We could just say it is 1025, 1026, 1027, but we do not give 1028. That would indicate that there is an isobar and which we cannot see. All right. Let's proceed to the question 1.3.4. What evidence in the area C shows that strong winds are experienced? What evidence shows that in area C, there are strong winds? All right. Let's go check area C. Now, this is our area C here. Our area C here. What can you observe at area C? Because we know winds are moved from a high pressure going to the low pressure. And we know that winds are very strong where isobars are close to each other. Therefore, when we check the question, it says, what evidence in area C shows that strong winds are experienced? Let's go back to the diagram. This is our area C, but like I mentioned, whenever you see these are isobars, right? These are isobars. But look, see how close they are to each other. You see, especially around this point. Isobars are so close to each other. And where isobars are close to each other, that shows it indicates a steeper gradient, or it indicates where the winds are moving very fast. So basically, you look at the isobars where they are too close to each other, that shows that the movement of the wind is very strong at that particular point. Therefore, when we say the answer here, what evidence in area C, winds are strong. So we could write and we say because the isobars are close to each other, isobars are close to each other. Now that is one of the indications to show that the winds are very strong. All right. So isobars are close to each other. That's one indication that strong winds are being experienced there. And as well, I can as well say, sorry, and as well say, we said isobars are close to each other. And that's what we could as well say that steep gradient indicated by the isobars. So that shows that the winds are strong in that particular point. Right. Let us proceed to question 1.3.5. They said, give a reason for the cloudy cover to the east of heat low pressure. Give a reason for the cloudy cover. The cloudy cover, the east of a heat low pressure. Now, what is a heat low pressure? Let's go back to the diagram here. What is a heat low pressure? We know well. Just try to illustrate again. Map of Southern Africa. Where in the interior here have LOP, meaning a low pressure cell, and the name of this low pressure cell is what we refer to as a heat low. Sometimes you can as well call it a thermal low pressure cell. So it is a heat low or a thermal low pressure cell. It does develop in summer due to intense heating of the land, therefore forming a low pressure. So in winter, because of there is strong subsidence, the thermal load disappears and the Kalahari will dominate the interior. So this is one of the indications to show that we are in summer season as a result of the presence of the thermal low. Okay, going back to our question, it says, give a reason for the cloudy cover to the east of a heat low pressure. Let's check the diagram here. This is a heat low, and say heat low here. They sent to the east of a heat low. Let me check it once. Let me check the question once again. Give a reason for the cloudy cover to the east of a heat low. So you can see, this is the east of a heat low. You can see, you see these dark spots. So all these ones are indicating cloudy covers. See, and if we check, all these are overcast cloudy covers. You see, what does that mean? That there are a lot of clouds that have formed to the east of a heat low. But the question is, let's check the question once again. Give a reason for the cloudy cover. Why are we experiencing a lot of overcast clouds at this particular point? That is the question. So you could say, if you go back to our blank page, reason for the cloudy cover, you could say because of a lot of evaporation taking place due to high temperatures. Due to high temperatures. Also, I could say there's a lot of humid from the South Indian high pressure resulting into high condensation. Another one as well say the inversion layer is above the escarpment. Inversion layer is above the escarpment, resulting into high cloud formation, which we refer to as condensation. All right. Let me try to illustrate these concepts below. They say a lot of evaporation taking place due to high temperatures. What is evaporation? Like we mentioned, ladies and gentlemen, when the temperatures are too high, water changes state from being liquid to vapor. So when this water changes, let's put water here as an illustration. This is water, high temperatures. So there is the sun there. High temperature. So this is water in liquid. So when it is too hot, now this water changes from being liquid to gas. When it rises to the dew point here, let's say it's the dew point, this was going to change into liquid again, which is the same as condensation, forming clouds. Right. So like that, that's why we say that in summer, because temperatures are too high, they make water to change from being liquid to gas, which ends up condensing at the dew point, forming clouds or a lot of humid from the South Indian high pressure cell, resulting into high condensation. If I illustrate that concept as well, this is Southern Africa here. This is the Indian Ocean here. Have the Indian Ocean. The Indian Ocean, it causes a lot of humid, which comes over the land on the eastern side, resulting into a lot of condensation taking place. And when there is a lot of condensation taking place, it means now we shall end up having a lot of clouds that are going to form. That will be for option number 2. If you check option number 3, where they say the inversion layer is above the escarpment, resulting into high cloud formation. Then we can as well do illustrate it here, and we show. Sorry. Okay, let us try to show this. We show our escarpment there. Show the inversion layer. Escarpment. I can try to show the inversion layer. So the inversion layer. Inversion layer. Above escarpment. So this means that we're going to shall have our moist air coming all the way humid from the Indian Ocean. So this is able to reach over the interior, and it's going to condense as well, resulting into overcast conditions. Remember, the question is asking why there are a lot of cloud formation. So we have indicated the clouds here due to the inversion layer being above the escarpment. This is the inversion layer. This is the escarpment or the plateau. So because we know that in winter the inversion layer does shift downwards, which might end up blocking the warm moist air from the Indian Ocean. But in summer, you can see it has shifted upwards from the escarpment, which is going to result into warm moist air reaching the interior to condense, forming clouds. And here we mentioned as well, we have the warm moist air from the Indian Ocean reaching the interior or reaching the eastern side, condensing, forming clouds. And as well here we said, because of high temperatures, water changes to vapor and resulting into condensation, forming clouds. So that is how we can try to answer that question. All right, let's proceed. Question 1.3.6 says, besides the date, what evidence suggests that this is a summer synoptic map? All right, we try to remove this, but we can have our synoptic map once again clear for visibility. Uh, um, all this. Right. So we have our synoptic map clear once again. They say, besides the date, what evidence suggests that this is a summer synoptic map? Our focus is on the concept summer. Summer, right? So how do we indicate or how do we tell that this is a summer synoptic map? Let's go to our blank page so that we can write down our answers. Good. The first evidence was just asking to give evidence. Evidence is what you can see, right? Among the evidences to show that this is summer, we can talk about the presence of a thermal low dominating the interior. So we can say presence of thermal low stroke heat low dominating the interior or land, right? That's one evidence. Like I mentioned before, if it was winter, in most cases, we're going to see the high pressure cell where they will indicate with an H here if it was winter to show that that's a Kalahari which is dominating the land if it was winter. But since we're in summer, we have the thermal law dominating the land. Another evidence can also talk about a lot of overcast clouds. You can see all these overcast clouds. It means clouds have been forming or developing. And this is common in summer. Because we know in summer, due to high temperatures, water is able to change state and then condenses, forming clouds. So meaning we could talk about presence of overcast conditions. Overcast conditions over the interior. Over the interior. Another evidence that we can talk about, can as well talk about the mid-latitude cyclone. I did hint before previously, it was the first question, that normally look at the position of the mid-latitude cyclones. You can see that they are far away from the land. See? So if this happens, so we are going to say that the mid-latitude cyclone, is situated far away from the land. And this is typical, or this is common in summer. Another evidence, can as well use distortion model for Durban. If you check on this distortion model, look at the air temperatures. Way high the dew point temperatures. See, so high temperatures also does does indicate that we are in summer season, right? Let's say high temperatures, high or air temperatures, and also high dew high dew point temperature. Remember, this is common in summer season. All right. Okay. Can I also talk about the two high pressure sources? Because we mentioned before that this is South Atlantic high and this is South Indian high. You can see that they are situated far away from the coast. See, this is South Atlantic high, situated far away, and this is South Indian high as well, situated far away from the land. So therefore, we can say that South Atlantic high, South Atlantic high, and South Indian high are situated far away from the land. Far away from the land. All right. Question 1.3.7. They say, with reference to the South Indian in bracket Mauritius high pressure situated east of Durban, explain the weather conditions experienced at Durban. All right, let's go to Durban. So this is the station model, which is found at Durban. Let me remove this, make it clear. Okay, so we can start with the wind direction is northeast, and we are going to say, let me draw another line here to separate this from this other question. Say wind direction is northeast as a result of anti-clockwise rotation. Sort of anti-clockwise rotation. Okay. Then another one. Let's go back to the station model. Look at the wind speed is just 15 knots. Say 15 knots. So you could say wind speed is 15 knots, which is due to isobars being far from each other. Isobars being far from each other. So you can see that around Durban, the isobars are stood far from each other. So one isobar here, another one here, and this shows a weak pressure gradient, which means the winds are not that very strong. This for is the identification. So you can see we have this iso by here, another one here. So if you look at around Durban, you can see that the pressure gradient is weak, which means the wind's speed was not high. See, all right. Let's check another concept, another condition. Okay. So we have overcast conditions. Overcast conditions due to a lot of moist air being fed from the Indian high pressure cell. So as you can see here, this is our Indian high pressure cell. So it brings a lot of moisture towards this other point. So this moisture is going to result into a high rate of condensation taking place, causing too much of the overcast. So it means that moist air is being brought to this point, moist air. So this moist air will end up condensing, forming a lot of overcast clouds over this other point. So that is why we say on our answer sheet, there will be a lot of overcast condition due to a lot of moist air being fed from the Indian high pressure cell. So if you go back again, you can see there are high temperatures. What is causing that? So you could say high temperatures due to warm air subsiding over Durban. So it means that a lot of warm air is coming from the interior towards Durban. As you can see here, we have a lot of air that is subsiding over the Durban area, resulting into temperatures to be that high. Then another one, the high dew point temperature, as well say high dew point temperature, which is due to a lot of moist air, being fed over Durban, meaning this warm moist air is going to result into high rate of condensation. All right. So that is question 1.3. Let us proceed to question 1.4, which talks about figure 1.4 shows the formation of a traveling disturbance known as a line thunderstorm. Right. So this is our figure below showing a line thunderstorm. Let's try to move faster. Question 1.4.1, they say, name the season during which line thunderstorms do occur. All right. Now, to understand this concept, we need to understand what is pressure gradient. Let's go back to our answer sheet. Understand what is pressure gradient. sorry, draw a straight line. Okay, this is much more better, right? Now, pressure gradient. So it refers to the difference in pressure. For example, e.g., we have point A, which has a high pressure, and point B, which has a low pressure. So you can refer to this as pressure gradient. As pressure, sorry, okay, so we're going to refer to this as pressure gradient, because you can see that area A has a high pressure and area B has a low pressure. Now, besides this, we need to as well understand how air moves. And we know that always air moves from a high pressure towards the region of a low pressure. So air moves from a region of a high pressure towards a region of a low pressure. And what is that air called? Being called, or it can be referred to as wind. Wind is moving air from the region of a high pressure, the region of a low pressure. Therefore, if we go back to our question to understand well, now we have a high pressure cell over this other area, and this another pressure cell over this other area. So they are showing us the movement of the winds towards this point here, which means at this point, there is a low pressure which they never indicated. So it means there is a pressure, let's call this one A, call this one B, call this one C. So you can see between A and B, there is a pressure gradient. What is pressure gradient? The difference in pressure between different places. So we do have a high pressure at A and a low pressure at B, which means now this A is moving from A to B. Again, from A is moving from C, this is C, to B, which makes region B to be our low pressure cell. It means that it is resulting into the movement of air from A to B, then from C to B. All right. Now, we did indicate before that what happens if you see a low pressure cell dominating the land. See, whenever you see this over the interior, it is an evidence to indicate that we are in summer season, because there is the presence of a low pressure cell, which we refer to as a heat low or a thermal low, which forms over the interior. Therefore, going back to our question, name the season which lightning thunderstorms occur. So we're going to say they develop during summer season. Okay, why summer? Because in summer, that is when we have a low pressure cell dominating the land over the interior, resulting into a pressure gradient being developed. Okay. Question 1.4.2. Name the two pressure systems responsible for the formation of line thunderstorms. Name the two high pressure systems. Two high pressure systems. I believe by now we must have understood the different high pressure systems. This one is our South Indian high pressure, and this other side we have our South Atlantic high. So those are the two high pressure systems for question 1.4.2. The two high pressure systems. We have South Atlantic high. If I can write them down, we have South, I'll abbreviate South Atlantic high pressure and South Indian high pressure. Good. Number 3, name two other conditions associated with line thunderstorms. So during line thunderstorms, what are the conditions? We're going to experience heavy rainfalls. Of rainfalls, there will be strong winds. There could be high chances of hail. There will be overcast clouds, but they only need two. All right, so those are the different conditions that will develop during line thunderstorms. Number 4, give a reason for the shifting of the Kalahari high pressure cell during a line thunderstorm. As I mentioned before, you can see that we don't see a Kalahari here, which means it has been displaced by the low pressure system or our thermal low. See? So, as I said, there used to be a high pressure cell here during winter, but in summer, it disappears. They're asking, give a reason for the shifting of the Kalahari high pressure cell during a line thunderstorm. All right, let's see. Okay, let's go back up blank page to try to understand question 1.4.4. So we could say that it does shift. It shifts due to weak subsidence, or because we can as well say there is intense heating of the land resulting into displacing of the high pressure cell. Right. Let's proceed to question 1.4.5. Okay. So for this question, as you can see, they say in a paragraph of 8 lines, evaluate the impact of line thunderstorm on farmers in the interior of South Africa. the impact. For this question, they're not being specific, and all of us know that an impact could be either positive or could be negative. So for this case, we could give both, or we could mix, or we could give either. All right, let's go to our answer sheet. Let us write down the impacts of line thunderstorms. Okay. One, brings rain, which favors crops. So could say rainfall could make the soil wet and good for farming. Number three, if rain falls, causes floods, which damages crops, floods results into the washing away of crops and soil nutrients. Strong winds could as well damage crops, etc. So there are so many of these impacts. All right. Question 1.5. Question 1.5, which says distinguish